Okay, so moving on, we have another function here, and we want to find the derivative. What I have to do here is apply the derivative of the function. Means take the derivative of each part of the sum. So I'm going to take 3 derivatives, like this. Derivative of the first one, I will use the rule x to the n, which its derivative is n times x, n to the negative 1. So I will do that here, and I will add something like 2 over 2, x, 2 minus 1, and plus 4 plus 0. Because remember that the derivative of a constant is 0. Here I have x plus 4. Yep, pretty much this is the answer to the second exercise. X plus 4. Now, number 3. Take the derivative of the following function. This one is also very easy. Remember that the derivative of the function, exponential function, is always the same. So y prime is the same minus 0, because the derivative of a constant is 0. So the answer is 2 times e to the x. That's it, right? Now, number 4. The position of a projectile being developed by NASA can be described with the following function. What is the acceleration of the projectile 1 second after launch? So for this problem, we need to remember high order derivatives. High order derivatives mean that you can take the derivative of function multiple times. And in physics, the first derivative is what we call velocity. And the second one is what we call acceleration. So for this problem, we need to take the second derivative of this function that they are giving us, and then replace in the point 1. Okay? That is going to give us the acceleration after 1 second. Let us take the first derivative then. For this one, I need to rule the chain rule. The function that I have here is a function to an exponent. You see? I cannot use the rule of x to the n, because what I have here is not x only. I have also other things. If I only had x, that's fine, I can do this. But here, I don't have x. I have 2 and a cube and a plus sign. That is not allowing me to use that rule as it is. I have to use that chain rule version of the function, of the rule here. So I will take n, u to the n minus 1, multiplied by the derivative of u. So, in simple terms, that is 2t cubed plus 1. I put the 2 on the left and I decrease it by 1. And then I also have to take the derivative of what is inside the parentheses, because chain rule. What is the derivative of that in the parentheses? That is 6t squared. And this on the left side is not changing, it's just as I left it. Yeah, something like this. Then 2 times 6, so 2t cubed plus 1, multiplying 12t squared. And then I will multiply this, 24 t to the 5 plus 12t squared, right? But this is just the first derivative. I need to find the second derivative. So I will derivate again. But this one is easier. For this one I don't need chain rule. I can just do 24 times 5 times t to the 4th plus 24t. You see? Now 24 times 5, that is 120. So this is 120 t to the 4 plus 24t. That is the second derivative. Yet now for the final answer, I only need to evaluate this in 1. Like this. That is going to give me 120 times 1 plus 24 times 1. Here, this is 120 plus 24. This is 144. Right? And that is the acceleration after 1 second. Now, number 5, take the derivative of the following function. We have sine cube x plus x. Here, I will also do the chain rule because I have u to the n. This is u and this is n. You see that I don't have x to the n. Instead of an x, I have a trigonometric function. That's why I have to use the chain rule. So, for this one, I will write 3 sine square of x. What I am doing here is applying this rule. And then what I am missing is multiply it by the derivative of u. What is u? Sine of x. What is the derivative of u? Cosine of x. So I just have to multiply this by cosine of x. And what is the derivative of x? That is 1. So this is the answer. 3 times sine square of x multiplied by cosine of x plus 1. Okay. Number 6. Take the derivative of the following function. For this one, you may want to use the product rule, or you can just do the multiplication before. That's faster. Or you can just remember the notable products. Here I have what we call a difference of squares, because I have x minus 1 multiplied by x plus 1. So I can rewrite this as x squared minus 1. And this is the function. This is the same function. And this is easier to take the derivative. The derivative of this is 2x. Okay, that's it. Just 2 steps. Number 7. Take the derivative of the following function. So I have a function e to the m, but I will rewrite this without fractions because I prefer to use the product rule over the quotient rule. So I will rewrite m as m to the negative 1. It's the same function, just rewritten. And if you remember the product rule, you have u times b squared v prime plus u prime times v. What is u here? This is u. And what is this? This is v. What is u prime? Well, it's the same because it's an exponential function. And what is b prime? That is negative 1 multiplied by m to the negative 2. And this is the same as 1 over m, like this. Okay. Now I will just apply the product rule here. I will write this in that order. So I have u times b squared plus u squared, which is also e to the m, multiplied by v, which is 1 over m, like this. And this is a possible answer. I notice here that I have some common numbers, so I can factorize here. I can factorize what is common, which is this, and then I will have 1 over m plus 1, like this. This is the simplest form we can rewrite this. And then for the last one, take the derivative of the following function. For it to have a chain rule over a chain rule over a chain rule. So this one's tricky, but it's not that difficult. You need to remember the formulas for derivative of the logarithm, for the sine, and yeah, pretty much that. So remember, whenever you have logarithm, natural logarithm of u, its derivative is 1 over u times u prime. So I will do that. I will write 1 over sine square of 3x to the 4th minus 1 multiplied by the derivative of all of this. Sine square 3x to the 4th minus 1, like this. Okay, fine. Now I will take the derivative of this. This is not going to change, so I will just rewrite it here. And then here, what is the derivative of this function? Well, I have to take the number 2 to the left side and take away 1. So instead of having this square, I will no longer have it a square. I will just have it at 2 minus 1, which is 1. 3x full minus 1 multiplied by the derivative of what is here inside, because chain rule again, multiplied by 3x to the 4th minus 1. You see, this is chain rule again. So this part here I will just multiply here. And here, what is the derivative of this? This is not harder anymore. I will not use chain rule after this. 3 times 4, that is 12x cubed, and the derivative of negative 1 is 0. So this is all. This is all. I can just like multiply some things here. Like, for example, this one is the same with this one. And I will multiply this 2 by this 12. That is 24 x cubed over sine of 3x to the 4th minus 1. You see? And yeah, I think this is pretty much the answer.